We are going to begin the part of our unit today talking about transformations of graphs. Today we're going to focus on vertical translations. There are quite a few different kinds of transformations, and this is the one we're going to start with. So when we look at that, here's our parent graph, y equals x squared, all the parent graphs we've done in the first half of the unit. And now I'm changing the parent graph by putting this plus 3 on the end. All right, so let's see what happens to the graph when I do that. So I'm going to substitute in some values, and we're going to see what happens. So when I put in 0 right here for x squared, 0 squared is 0. I'm going to do the same thing for 1. I'm going to put in 1 for x squared. 1 squared is 1. All right, and now I'll do 2. 2 squared is 4. Okay, so for my parabola parent graph, these are the values that I would get. Okay, so now let's look what this plus 3 does. When I put 0 in for x, just like I did before, 0 squared is 0, plus 3 is going to give me 3. 1 squared is 1, plus 3 is going to give me 4. Now I'll put in 2. 2 squared is 4, plus 3 gives me 7. So if I look at the values that I originally got here and the values that I got of my transformed graph here, I can see that all of my y values increased by 3. So if you think of where that is, here's your x-axis, here's your y-axis. If all of my values on y increase by 3, that's going to have the effect of moving my entire graph up 3 units because every y value is going to go up by 3. Okay, let's see what happens when we subtract. So this time instead of x squared, I chose x cubed. But we're going to do basically the same thing. We're going to substitute in some values to the parent graph, and then we're going to substitute some values into this transformed graph with the minus 3 and see what happens. So when I put in 0, 0 cubed is 0. All right, I'll put in 1, 1 cubed is 1. And now I'll put in 2, 2 cubed is 8. Okay, now let's come over here to this one and let's try the same thing. I'm going to put in 0. 0 cubed is 0 minus 3 is negative 3. Put in 1. 1 cubed is 1 minus 3, negative 2. And now put in 2. 2 cubed is 8 minus 3 is 5. So again, if I look at my original values that were in the parent graph and I compare those to my values in the transformed graph, what we can see is all of those y values went down 3 units. So again, if my parent graph is here, right, there's x cubed, and I take every point, infinite number of points, and I move them all down 3 units, I'm going to have that same shape. The shape of the graph is not going to change, just its location. It's going to move down 3 because every y value is going to decrease by 3, and this is my y-axis, so they're going to move down. So what we find is when we subtract or when we add a value on the end of the function, kind of on the outside of the function, it has the effect of moving the graph up or down that many places. Okay, so write on your paper, positive numbers move the graph up. Negative numbers, like we looked at on the other screen, move the graph down. Okay, so when those values are outside of the function, positive numbers move the graph up, negative numbers move the graph down. Okay, let's look at what that looks like on any particular parent graph. It doesn't matter what your parent graph is. Any of those parent graphs that we looked at, algebraic or trigonometric, they all work exactly the same way. That's why I wanted to do them all in the same lesson. So, in the same unit. So this minus 4, I can see that's outside of the square root. So this is going to be a vertical shift, a vertical translation. I'm going to move this square root curve down 4. So if I look at it, this point right here where it begins, it's just going to go down 4. Now normally the square root of 1 is 1, but I'm going to subtract 4 from that. So at 1, I'm going to be here at negative 3. And it's going to continue like that. It's going to keep that same shape, that same growing slowly slope. It's just going to be shifted down on the y-axis. So you would end up with a shape somewhat like this. And when I get out to 16 is when it's going to cross the x-axis, because the square root of 16 minus 4, square root of 16 is 4, 4 minus 4 is 0. So that's going to cross the x-axis way over there at 16. It's just going up very slowly. But you can see that every point essentially went down 4 over the whole curve. Everything went down 4. All right, let's do another one. Let's look at this one. So this time I've got my exponential growth. You can see a is greater than 1 and my x is just x up there in the exponent. Okay, now this is where the anchor point comes in. You remember my anchor point was right here on 0, 1, because anything other than 0 raised to the 0 power is 1. And you also remember I had a horizontal asymptote right here on the x-axis, the negative part of the x-axis. Well, what's basically going to happen when I move this graph up is that both of those graphical features, just like every other point on the graph, are going to move up also. So let me make this one orange. All right, if I take that anchor point and I move it up 1, it's going to be here. And if I take that asymptote that was on the 0, it was on y equals 0, so now it's going to move right here to y equals 1. And then I'm going to make that same shape that I had before. So my graph, my transformed graph that went up 1 unit, asymptote right there, through the anchor point, and then up. So there's my transformed graph. Every point on this graph went up 1 to get to the new graph. So all the way across, every single point is going up 1. And the ones that we're going to focus on, the ones that are going to help us put this in the right place, are the anchor point and the asymptote. If we move both of those up 1, the rest of the graph will just kind of follow. Okay, let's do a couple trig graphs. So here is a sine curve. You can see I've gone 2 pi radians on the right and the left. And this tells me I'm going to move up 2. Okay, so think about what we know about the sine curve. The sine curve midline is right here on the x-axis. So what I'm going to do is I'm going to move the midline up 2. So I'm just going to put a dotted line right here. This is not an asymptote. This is just me moving the midline so that I can aim. And then you remember the amplitude. Well, the amplitude was 1. So I went to the highest point up 1 from the midline, and the lowest point was down 1 from the midline. So I'm going to do the same thing here. I'm going to go to the midline, and I'm going to go up 1. So if my midline is at 2, up 1 is going to be at 3. And if the midline is 2, then down 1 over here, down 1 from 2 is 1. All right, and I'm going to do the same thing on the left-hand side of the graph. Right here, I'm down 1. So I'm going to go down 1 from my midline. And then over here, I'm up 1. So I'm going to go up 1 from my midline. And then I'm also going to mark the places where I hit the midline. So you remember sine of 0 is 0. Sine of pi is 0. That's right there, about 3.14-ish. Sine of negative pi is 0, and sine of both negative and positive 2 pi are 0. And then I can just connect the dots, make it a nice smooth curve. Try to make the places where it turns very smooth and not pointy. Really goes on and on forever in both directions. And so there is my sine curve moved up 2. Okay, let's do this one. Let's do secant. So here I have graphed secant of theta. And then here I put in some dotted lines to help us remember some things. So secant, you remember, is the reciprocal of cosine. So I have dotted in right here in blue, this is cosine. And you remember that secant has asymptotes everywhere that sine crosses the x-axis. So in green right here, I've got my asymptotes. So it turns out with secant and cosecant, instead of moving this original graph up or down, it's easier to move the one that it's associated with. It's easier to move cosine or sine and then draw secant and cosecant once I get the sine or cosine curve dotted in where I want it to be. Since this is secant, I'm focusing on cosine. If this had been cosecant, then I would have graphed sine right here. So let's look at this one in a little bit more detail. Okay, so I have taken the actual secant curve away, and I just have cosine here, and I have where the asymptotes for secant would be everywhere that cosine crosses the axis. So when I move this down one, just like I did with sine, what's going to move down one, first of all, is my midline. My midline was right here on the x-axis at y equals 0, so I'm going to move that right here to y equals -1. Remember, this is not an asymptote. This is the midline. This is just to help me graph it. Okay, now look what happens when I slide the whole thing down. That does not in any way affect where my asymptotes are. I can move up and down however high or low I want without changing the asymptote. So I'm just going to leave those green ones where they are. Okay, now I'm going to dot in cosine, remembering that this is my midline. My amplitude of cosine is 1. So everywhere that I have a peak, I'm going to go up 1 from the midline, which is going to be here and here and here. And everywhere that I have a valley, I'm going to go down 1 from the midline, which is going to be here and here. And you can think about this as part of the unit circle. You can think about the fact that cosine of 0 is 1. Same for 2 pi and negative 2 pi. Cosine of both pi and negative pi is -1. And then where my midline crosses the axis right there, my new midline, I'm sorry, crosses that asymptote, that's where I would have a 0. So I'm just going to dot this in. Okay, again, this is not an asymptote. This is just me dotting in cosine so that I have something to aim for. Okay, so now I'm ready to do secant. Secant is the only thing that's going to be solid. Everything else that's dotted is just there to help me draw secant. It's not really part of the answer. Only the solid things are part of the answer. So if I go to the top right here and flip my bowl, right, remember going to the asymptote on both sides. And here I'm going to flip also, going down toward the asymptote. This one is going to go up. This one will go down, just flipping all those bowls in the opposite direction. So if you look at the red, only focus on the red. Look at the red that I have here, and then look at the red that I have here. You can see that this one, the bowls are at +1 and -1, and here in between +1 and -1, it's empty. Well, now I've moved everything down 1, so my bowls are touching here at 0 and -2 instead of 1 and -1, and then in between 0 and -2, it's empty. There is no red inside of there.